Hey everybody, wanted to show you a quick demonstration of some of the dangers of making some assumptions before taking some voltage readings. So one of the things that I have learned along the way, and unfortunately has cost me a fair amount of time to learn, is that these circuit boards that are used in these units unfortunately can be powered up with 120 volts, and it will take off the appearance that everything is working. As you can tell here, the lights on this board are lit up and working. And if you look at our voltage coming in, you'll notice that it is only 120 volts. Okay, so what happens is that when you go to make the DC voltage reading, you're going to check that DC voltage here. And you notice how from our other video, how the pulsing voltage, you'll still get a little bit. Let's range it out. You'll still get similar voltage, but notice that how it's not going near as high. And if we go over here on our inverter board and we go and check the DC voltage over here, and you'll notice that it's significantly less at 165. So let me switch this around. Let me put it to 240 volt. And then I'm going to show you how that differs. One other thing to remember is that if you watch these lights, it takes a good solid minute or two for everything to power down. And if you would really are interested in it, you can leave your meter over there on the inverter board. And that'll offer you up some insight into how long it takes the boards to discharge and for everything to end up being safe for you to go ahead and start using again. Go ahead, yeah. Okay, so now that everything is dead, the boards are dead, we're gonna re-energize the power supply, and it's on. So let's check here. AC volts coming in. We've now got 240 volt. Okay, so let's reread that DC voltage reading, ranged out to 600 volts. So you're getting a spike up to 130 or so. Then we'll go ahead and remake this reading over here on the inverter board. And you're now getting 332, which is about what you should, given what the voltage is. So this is a multi-split chassis. While we're talking about this, I'm going to talk to you a little bit about the how you get the voltages that you get. So first off, you get power incoming here. Then it travels to the power board where it goes through a fuse, a couple set of fuses, one here, one here. Those are what protects the 1 and 2 for the indoor unit wiring and the indoor units themselves. So this is your 208, 230 volt power feed out to the indoor units here. This is number 3 is your communication as well as your number 2. The big fuse here on the power board protects the power that comes back to the main control board right here into here. So this fuse protects this. Then after that occurs, then we send the we send AC voltage through here out to the inverter board, where we rectify it on the diode bridge, which if you look, it is going to be right here on the diode bridge. Then you're going to go out here, DC voltage, to normally you'd go to the active filter module on the black, and the red would land here. Then it would come out the blue and yellow. You'd also have a choke coil attached to here. It would come out blue and yellow, come back to the inverter board where it uses the IPM portion, would drive the compressor. Then you also have a crossover cable that takes DC voltage back over here to the main control board so that it can be used for the outdoor fan motor output, which is this guy right here. So there's a lot of stuff happening between the boards. When you understand what exactly does what to who, makes life a whole lot easier. to understand. You'll have a couple AC voltage outputs right here, which is your reversing valve, and then a crankcase heater option there as well. You'll also have some wires here, which are communication wires between the inverter board and the main control board. They're constantly talking, sending data back and forth. This one is as well. This one is another inverter board communication cable that goes in between. Expansion valves are all up here in this region. The thermistors are all right here. I pulled all the two-way, three-way thermistors out of here because they were just getting in the way for what I was trying to do. So also note that you'll see these little blue rubber deals over the top of the fuses. These will come off if you just grab them with a needle nose with the power off. Pull those off, you'll be able to check the fuses. These ones over here are actually removable. You'll move the rubber off of it, and then the fuse just clips in. So other than that, I just wanted to cover those couple electrical basics here with you on this machine, as well as these rows of dip switches. You'll have to look in the manuals to see what they do. On this particular model, you got one that the first one operates whether or not you run test mode and heat and cool. Second one is going to change it from test mode to pump down for service. If you need to shut the liquid line, then you can pump the unit back down into the outdoor unit, so you can do service work on flares, inside, indoor units, whatnot. Then the other ones are, one of them will dictate whether or not it has a base pan heater or not, and then the other ones have other functions that none of us really are real sure what they do. So that is this structure in a nutshell. I hope you enjoyed it, and I will look forward to seeing you on the next one.